Hello friends, there is a important classification of fold known as Ramsay's classifications of fold, and this is provided by a British geologist known as John G. Ramsay. And there are some important terms. These are axial plane. Axial plane is the imaginary plane passing from the hinge line dividing the fold into two equal halves. Deep isogon, the line joining the same point of deep either side of the layer. Orthogonal thickness is the perpendicular distance between the inner and outer bounding surface of the folded layer, and the axial trace thickness, the distance between the two parallel tangents of the folded layer measured parallel to the axial plane of the fold. Then inner curvature, inner arc of the folded layer. Outer curvature is the outer arc of the folded layer. Interlimb angle is the smallest acute angle between the two sides of the fold. So as you can see, this is the deep isogon, which joining uh, the point of equal dips, and orthogonal thickness is the perpendicular distance between the two tangents, and the axial plane axial trace thickness is the distance that is parallel to the axial plane. So criteria of classification: nature of the deep isogon, that is deep isogon is either convergent or divergent, and outer and inner curvature, interlimb angle, thickness of the limb, thickness of the hinge area. So class 1 fold, deep isogons are convergent, inner curvature is greater than the outer curvature, interlimb angle is 0 for, and as you can see, the deep isogons are convergent towards the center. Then it is further divided into three classes. Class 1A, where the limb is thick and hinge is thin. As you can see in this picture here, limb is thicker and hinge is thinner. And class 1B, equal thickness throughout the fold. As you can see, the thickness of the hinge and limb is equal throughout the fold. This 1B is also known as parallel fold. Then 1C, then class 1C is where limb is thin and hinge is thick. As you can see, the limb of the fold is thin and hinge of the fold is thick. And then class 2 fold is where deep isogons are parallel to each other. As you can see, this is also known as similar fold, and inner curvature is equal to the outer curvature. Orthogonal thickness varies along the fold, being the thickest at the hinge and thinnest at the limb. It is found in metamorphic and highly ductile rocks. Then class 3 fold, where deep isogons are divergent. As you can see, the deep isogons are diverging from the center, and the curvature of the inner arc is the greater than the curvature of the inner arc is the curvature of the outer arc is the greater from the inner arc, and hinge zone is notable thicker than the limb area. So it is found in incompetent layers like shells and mudstones. Thank you.